Dear students, in this module titled Construction of Life Tables and Fertility Rates from Sample Registration Data, we will be covering the major aspects of the methodology for construction of life tables from sample registration data and various fertility rates from sample registration data, how they can be constructed and what are its interpretations. That is the main focus of this module. A life table is designed essentially to measure mortality. It is a statistical model from which the measures of mortality are derived. It is employed by variety of specialists in a variety of ways. It is used by public health workers, demographers, actuaries and many others in the studies of longevity, fertility, migration and population growth, as well as in making projections of population size and characteristics. It is used in the studies of widowhood, orphanhood, length of married life, length of working life and length of disability free life. In a nutshell, the entire life table is generated from age-specific mortality rates and the resulting values are used to measure mortality, survivorship and life expectations at different age groups. Life tables are one form of combining mortality rates of a population at different ages into a single statistical model. It depicts the level of mortality of the population involved. One of the main advantages over other methods of measuring mortality is that they do not reflect the effects of age distribution of an actual population and do not require the adoption of a standard population for acceptable comparisons of levels of mortality in different populations groups. Another is that a life table readily permits making mortality allowances for age cohorts, eliminating the burdensome task of compiling death statistics for age cohorts from annual death statistics by age, even when the latter are available. Life tables differ according to the reference year of the table, the age details and the number of factors comprehended by the table. There are two types of life tables according to the reference year of the table, that is 1. The current of the period life table and 2. Generation or cohort life table. The first type of table is based on the experience over a short period of time, such as a year, 3 years or an intercensal period in which mortality has remained substantially the same. This type of table represents the combined mortality experience by age of the population in a particular short period of time, treated synthetically or viewed cross-sectionally. It does not represent the mortality experience of an actual cohort. Instead, it assumes a hypothetical cohort that is subject to the age-specific death rates observed in a particular period. Hence, a current life table may be viewed as a snapshot of current mortality. The generation life table is based on the mortality rates experienced by particular birth cohort. For example, all persons born in the year 1880. According to this type of table, the mortality experience of the persons in the cohort would be observed from their moment of birth through each consecutive age in successive calendar years until all of them die. Obviously, data and a long period of years are needed to complete a single table, and it is not possible wholly on the basis of actual data to construct generation tables for cohorts born in this century. This type of table is useful for projections of mortality, for the studies of mortality trends, and for the measurement of fertility and reproduction. In general, current life tables are constructed to know the mortality levels. Life tables are also classified into two types, that is complete or unabridged and abridged, according to the length of the interval in which the data are presented. A complete life table contains data for every single year of age from birth to the last application age. An abridged life table, on the other hand, contains data by intervals of 5 or 10 years of age. The simpler abridged life table is usually prepared rather than the more elaborate complete life table. Values for 5 or 10-year intervals are sufficiently accurate for most purposes, and thereby the abridged table is less burdensome to prepare. It is also more convenient to use for various demographic analysis. The table clearly depicts from the current life table from sample registration system data the various age specific death rates for each sex and rural and urban, which are taken from sample registration system of 2015 data. From these rates, the entire life table is constructed through the following steps. Step 1. Calculate the NMX values from the age specific death rates of males and females from sample registration system using the formula ASDRs, that is number of deaths is in age group divided by population of that age group multiplied by 1000. In a formulation, it is the NMX is equal to age specific death rate by 1000, where NMX is the observed death rate in the given interval x to x plus n age. Using the above NMX values, the other columns of the life table are constructed as usual except the NQX values. Here, G is Greveles method of conversion of NMX into NQX is used. The formula is NQX is equal to NMX by 1 plus NMX upon L to the power n plus n power mx minus log c to the base e, where c comes from an assumption that the NMX values follow an exponential curve. Empirically, the value of c has been found between 1.08 and 1.10. Log c to the base e could be assumed to be about 0.095 as an intermediate value. Using this method, the observed death rate was converted into the probability of death in each age group. NQX is the probability of dying between age x to x plus n. This is n dx formula based on the assumption deaths will occur between ages x to x plus n if an average in the middle age. Now, let us discuss about this step 2, the number of deaths from age x to x plus n. N elects the number of people living at the beginning of age interval. For the first age group 0 to 4 years, we assume that there will be 1 lakh births, that is a cohort of births, which is usually called a radix of the life table. NLX is equal to NDX divided by NMX. N capital Lx is equal to number of years of life lived by the cohort between exact age x to x plus n. For the last age interval, alpha Lx is equal to small lx by alpha mx. Next, NTX, that is number of persons lived who had completed the age or total number of years lived above the age group. Using the above steps in life table for total persons, total males and total females were constructed for all India, which is given in the tables 2 to 4. Let us discuss now the fertility rates that are derived from sample registration system. Sample registration system SRS has been providing data for estimating various fertility measures since its inception. The following fertility rates are calculated from sample registrations data. They are crude birth rate, general fertility rate, age-specific fertility rate, marital fertility rates, total fertility rate, marital fertility rates and gross reproduction rate. Let us detail these measurements which uses the sample registration system data. To begin with, let us focus on crude birth rate, which are usually called as CBR. Crude birth rate at all India level had been shown to be declining from 36.9 in 1971 to 33.9 in 1981, registering a fall of about 8%. During 1991 to 2010, the decline has been about 25.1% and further that has come from 29.5 to 22.1. The details are presented in table 5. The total fertility rate in rural areas, which has declined from 5.4 to 2.8 during the period 1971 to 2010, whereas the corresponding decline in urban areas has been from 4.1 to 1.9 during the same period. The data on most of the fertility indicators has been presented by age, sex and residence for all India and also bigger states. It also includes data on fertility by level of education, order of birth, birth interval and medical attention at birth. The table provides the indicators referring to crude birth rate categorized separately for residents, India as a whole and the bigger states for the year 2010. Next refers to the general fertility rate, commonly known as GFR. Estimates of GFR, a refined measure of fertility defined as the number of live births per 1000 women in the reproductive age group 15 to 49 years, is a useful tool for measuring the fertility levels. The general fertility rate for all India and also for bigger states are given in the table separately for rural and urban areas. At the national level, the data shows that there are 83.9 children who are born to every 1000 women who are in the age group of reproductive age of 15 to 49 years. This number varies from 64.0 in urban areas to as high as 91.9 in rural areas. If we analyze among different states, the general fertility rate has shown that it varies from 52.8 in the state of Kerala to as high as 120.1 in the state of Bihar. The chart gives a clear pictorial comparison of the bigger states by level of general fertility rate. The distribution of bigger states by residents and levels of general fertility rate is presented in the chart, and from which it is observed that the general fertility rate in rural areas of Kerala is just higher than the urban areas, with a minor difference of 0.5, which clearly reveals that the rural urban differences in the state of Kerala is not varying that much compared to the other states. Next, the table clearly gives the various levels of general fertility rate by residents, India and bigger states 2010, and overall it clearly reveals the huge variations that exist in the general fertility rate among rural urban and also across different bigger states as revealed for the data of 2010. Let us focus on the third measurement of fertility, that is age specific fertility rates. Age of women is an important factor affecting the fertility levels. On the basis of data on births to women by specific age groups living in the reproductive age span of 15 to 49 years as available from sample registration system, the age specific fertility rates have been calculated. The table gives the age specific fertility rates for India by residents, that is rural urban, and the data reveals that the fertility in all the age groups is consistently higher in the rural areas than compared to that exists in the urban areas. The fertility reaches the peak in the age group of 20 to 24 of age of woman and declines thereafter, and it is found to be irrespective of the place of residence of both rural and urban areas. Age specific fertility rate curve for urban areas falls under the age specific fertility curve of rural areas. Also, the rural area age specific fertility curve has declined very steeply after attaining peak for age 20 to 24 years, whereas the age specific fertility curve of urban areas has gradually declined up to the age of 25 to 29 years after attaining its peak at the age of 24 years of woman. The table clearly provides the data on age specific fertility rates by residents, that is rural and urban, in India as per 2001 data. The various age groups and very clearly reveals that the age specific fertility rate is as low as 37.2 in the early ages of reproductive span of women, that is 15 to 19 years, but huge variations exist in this age group between rural and urban areas. For instance, in 15 to 19, the age specific fertility rate for rural areas is as high as 43.1 as compared to the low level of 19.6 in urban areas. When we look at the next level of higher age group of 20 to 24, it is very clearly shown that it is at the peak level by showing the total age specific fertility rate for the total population is as high as 198.6, and furthermore in rural areas it is at very high level of 218.5 as compared to urban areas age specific fertility rate, that is 147.3. In the next level of 25 to 29 years of age, the total population, we notice that age specific fertility rate refers to 156.8, and here in the rural areas it is relatively higher of age specific fertility rate of 167.5, and in urban areas the rate refers to 132.9. From here of that age group onwards, there is a consistent decline in the rate. For instance, in the age group of 30 to 34, the age-specific fertility rate in total population refers to 66.0, and as usual in rural areas it is relatively higher of 70.1, whereas in the case of urban it is 56.2. And the next level of age group, that is 35 to 39 years, the total fertility rate, the total population has shown the age-specific fertility rate of 29.7 years, whereas in the case of rural it is 34.5 years, and in urban 18.1 years. And further, when at the advanced age of women, that is 40 to 44 years, the age-specific fertility rate as expected in the total population, it is as low as 9.3 only, and in rural areas the level refers to 11.6, and in urban areas it is as low as 3.8. In the last age group interval, that is women in 45 to 49 years of age group, the age-specific fertility rate is the least level, that is only 3.9 in the total population, and in the case of rural areas it is 5.2, and in the case of urban it is the least, that is only 1.0, which clearly depicts that age wise the age-specific fertility rate clearly shows that huge variations exist across age groups, and furthermore the rural urban differences are vividly observed with respect to age-specific fertility rates, clearly indicating that age of women has a strong bearing on the fertility level of this population. The next table refers to the percentage change in the age-specific fertility rates by residents between 1998 to 2000 and 2008 to 2010, that is in all India, and this across different same age groups. When we refer to rural urban differences, the change is very clear how the rural urban differences have experienced the age-specific fertility rates, and how the ages wise the differences, how it differs across these rural and urban is very clear. So, this is one important thing which we need to notice. The next variations is the fertility pattern by age groups in different states as given in the table. Except for the states of Delhi, Jammu and Kashmir and Uttar Pradesh, where fertility level reached its peak in the age group of 25 to 29 years, the highest fertility in all the other bigger states have been attained in the age group of only in the 20 to 24 years. Fertility level, however, declines after age 30 in almost all the bigger states. The age-specific fertility rate in the younger age group of 15 to 19 years varies from 6.7 in Jammu and Kashmir to as high as 73.8 in West Bengal. In the age group 30 to 34, the variation in the level of age-specific fertility rate is from a low level of 22.3 in the state of Andhra Pradesh to high levels of 116.2 in the state of Bihar. The rural urban levels in age-specific fertility rate for these states are shown in the table, and which clearly reveals that the variations across states are very huge, and also in the different age groups the levels have widely differed, and not only across different age groups but also among the many states within the country of India. The cumulative fertility for a specific age group has been worked out by adding all the age-specific fertility rates up to that age group. The percentage share of fertility by women in the age group of 15 to 19 years varies from 2.0, which is minimum in Jammu and Kashmir, to as high as 20.5 as observed in the state of West Bengal. By the age of 34, the percentage share of cumulative fertility varies from 88.4 in Jammu and Kashmir to 98.7 in Andhra Pradesh state. The percentage share in cumulative fertility for women by the age 39 years varies from 96.7 in Jammu and Kashmir to 99.8 in the state of Karnataka. At the national level, for the country as a whole, less than 2% fertility is from women aged 40 years and above. Let us discuss the other refined measurement of total fertility rate, usually called as TFR. The cumulative value of the age specific fertility rates at the end of the childbearing ages gives a measure of fertility commonly known as total fertility rate, TFR. TFR indicates the average number of children expected to be born per woman during her entire span of reproductive period, assuming that the age specific fertility rates to which she is exposed to continue to be the same and that there is no mortality. The TFRs for the year 2010 are given in the table for India and bigger states, separately for rural and urban areas. The TFR for total India was 2.5 per woman, and residence wise data shows that it is relatively higher for rural areas to extent of 2.8, and it is low in urban areas, that is at the level 1.9. Among the bigger states, it varies from TFR of 1.7 in the state of Tamil Nadu to the relatively higher level of 3.7 in Bihar. For rural areas, it varies from 1.8 in Punjab, Kerala and Tamil Nadu to 3.8 in Bihar. For urban areas, such variation is, when we analyze, it is shown that the variation is 1.3 in West Bengal and Himachal Pradesh to a higher level of difference of 2.7 in the states of Bihar and Uttar Pradesh. The table clearly shows that the extent of variation is very well observed across the different states and also between rural and urban areas, which clearly indicate that there is a need to differentiate the interventions in rural and urban areas and also across different age groups in the community when we refer to the woman. The next level of measurement comes out is the gross reproduction rate, commonly known as GRR. Another refined measure of fertility which accounts for future mothers is called GRR. It measures the average number of female children a woman is expected to give birth during her entire reproductive span, conforming to the age specific fertility rates, that is ASFRs, for a given year if there is no consideration of mortality. The estimated value of gross reproduction rate for India in the year 2010 is 1.2, and rural urban differences are also noticed. For instance, the GRR is 1.9 in urban areas, whereas in the case of rural areas it is relatively higher of 1.3. The table gives the gross reproduction rate residence wise between rural and urban for India and across different states, which clearly shows the variations that exist, and the gross reproduction rate has shown of different levels between rural and urban areas. The next level of measurement is marital fertility rates, that is which is derived from sample registration systems. Based on the distribution of live births by age of married females alone, the age specific marital fertility rates are calculated. The table gives the estimates of age specific marital fertility rates for India, again separately for rural and urban areas. Marital fertility rate is higher in rural areas than in the urban areas and also on all the age groups, and it is a peak in the age group of 20 to 24 years. A perceptible decline in marital fertility is seen for the female of age of 30 years and above, both in the case of rural areas and also in urban areas, which clearly reveals that there exists a huge differences in these levels between rural and urban areas. Age specific marital fertility rates for bigger states, which is given in the table, clearly observes that the age pattern of marital fertility is almost similar to the pattern of age specific fertility rate. The marital fertility rate in the age group of 15 to 19 years is lesser than the national average in half of the bigger states, namely Andhra Pradesh, Bihar, Chhattisgarh, Delhi, Gujarat, Jammu and Kashmir, Kerala, Madhya Pradesh, Maharashtra and Rajasthan. Age-specific marital fertility rate is at peak level in the age group of 20 to 24 years in all the bigger states except Assam, Jharkhand, Odisha, Tamil Nadu and West Bengal. There is significant decline in marital fertility for women aged 30 years onwards for all the major states, which clearly depicts the variations, and that is how the table clearly shows across different age groups between rural and urban areas among the major states. Next comes the measurement of total marital fertility rate. TMFR is the cumulative value of age-specific marital fertility rates at the end of the reproductive period. It indicates the average number of children expected to be born per married woman during the entire span of her reproductive period if the age-specific marital fertility rates continue to be the same and if there is no mortality. The total marital fertility rates as given in the table for India and bigger states separately again for rural and urban areas clearly showed that the total marital fertility rate for India as a whole is found to be 4.4, and it varies again with a low level of 3.8 in urban areas to 4.5 in rural areas. The total marital fertility rate is 5 and above in the states of Assam, Bihar, Jharkhand and Uttar Pradesh. The table again shows the age-specific marital fertility rates, the total marital fertility rates across different states, and very clearly the variations are significant between rural and urban areas. And overall, this module has clearly showed that the life table is an important tool for estimating the various age groups, and also there over a period of time how the life expectancy moves is an important indicator. The other aspect is that through the sample registration system, it is possible to estimate the vital rates in the fertility, and starting from crude birth rate, age-specific fertility rate, age-specific marital fertility rate, total fertility rate, again total marital fertility rates and gross reproduction rate, and these measurements with respect to separately for rural and urban areas with each of these specific age groups of women clearly gives the scientific way of analysis and presentation of the levels of fertility is possible, which provides for further analysis in the demographic analysis. Thanks.